Okay, this is your homework help for Unit 11, Objective 1. A reminder that this is not designed to replace the notes. It is designed to help with homework in case you need to see one more done, need to check an extra practice one, something along those lines, right? It is not designed to replace the notes. So if you have not watched the notes, you need to stop the video, go over to the notes video, and use that instead. Okay, we are going to be doing 4 problems here, numbers 3, 7, 11, and 13. Okay, so starting with number 3, if you haven't already done number 3, go ahead and pause the video, give number 3 a shot, restart the video when you are ready. Okay, when we take, in number 3 here, our x approaches 3, when we take the 3 and plug it in, we get 1 over 9 minus 1 over 9, which is 0. Over 0, we can't have 0 over 0, so what are we going to be doing? Okay. Well, we are going to be multiplying by our least common denominator, okay? So what would be my least common denominator for this one? It would be 9 and x plus 6. Remember that if you do that to one function, you need to do it to the other as well. Okay, and because I'm going to need a little bit more space here, I'm going to go ahead and cover up number 6. That way I've got my extra space. Okay? So here we go. Distributing to our numerator here, we have the limit as x approaches 3 of, in the first term, the x plus 6's would cancel, leaving me with a 9, minus, in the second term, the 9's would cancel, leaving me with the x plus 6. In the denominator, we have the x minus 3, the 9, and the x plus 6. Okay? Now remember, make sure that you are not simplifying these x plus 6's. I know it's really tempting to do so, but because our numerator, all those different pieces are not being multiplied together, they therefore are not one term, and so I cannot simplify, simplify numerator and denominator until I first simplify within my numerator, distributing, combining like terms, that kind of thing. Okay, and so in this case, I'm going to go ahead and distribute that negative. So we have the limit as x approaches 3 of 9 minus x minus 6. Okay, which allows this 9 minus x minus 6 to simplify to 3 minus x. And so then maybe you got to that point, you're sitting there going, man, I have got a 3 minus x in the numerator and x minus 3 in the denominator. It would be really nice if those could simplify. Well, they can, if I factor a negative out. Right, if I factor a negative out of that numerator, I get the limit as x approaches 3 of negative, and then this would be x, positive x, and minus 3, negative 3. And I therefore am then allowed to simplify. My x minus 3's would cancel. I'd have a negative 1 left on top. And on bottom, I would have a 9 times, plug in my 3, 3 plus 6 is 9. 9 times 9 is 81. Okay. Okay, number 7. If you haven't done number 7 yet, go ahead and pause the video, give number 7 a shot, restart it when you are ready. Okay. Okay, with number 7, I'm also going to need a little bit of space, so let me go ahead and add in my post-it note here. Because, oops, looks like I need to fold that a little bit further. Because we have some work to do. When I plug in 2, I get root 2 plus 2, or root 4, which is 2, minus 2 is 0, over 2 minus 2 is 0. I can't have 0 over 0, so what am I doing in number 7? I'm multiplying by the conjugate. And which part of the fraction, numerator or denominator, am I looking for my conjugate? Or looking at for my conjugate? Okay, that would be the numerator. Okay, so remember conjugate, the two terms stay the same, but the sign in between changes. So we have root x plus 2 plus 2. Okay? Remember, nice thing about a conjugate is the outside and inside will always end up canceling. Okay, so in my numerator here, root x plus 2 times root x plus 2 is x plus 2. The outside and inside will cancel, and I'll be left with the last then at the back. Negative 2 times positive 2 is negative 4. In the denominator, I have x minus 2 and root x plus 2 plus 2. Okay, well, x plus 2 minus 4 is x minus 2. And so those would cancel, leaving me with x, limit as x approaches 2 of 1 over root x plus 2 plus 2, which is 1 over root 2 plus 2, or root 4. So 2 plus 2, which is 4. Okay? Okay, number 11, we have the limit as x approaches 2 of f of x, where f of x is given. Okay, remember when we are evaluating limits of piecewise functions, we need to check our left limit and our right limit. Okay, so again, if you haven't tried number 11, pause it, restart it when you're ready. Okay, which function is our left limit function? Okay, well remember, left is less than, so my left function is the upper one. X is less than 2, and so that's my upper one. Plugging my 2 in then, this 2 here, into that function. We have 2 squared minus 2, which is 4 minus 2, or 2. Which one's my more then? I'm sorry, which one is my right? Okay, my right is my more than, which is the bottom one. X is more than 2, greater than 2. So I'm plugging 2 into that bottom one. 2 plus 1, which is 3. Remember that the equals, I made the recommendation in the notes that if you think you're going to get thrown off by equals, start the problem off with crossing off equals. Equals, one more time from the notes, is the point of the function. It has nothing to do with the limits. And so make sure that you are never getting distracted by the equals part of your piecewise function. Okay? And then you're asking yourself, okay, we've done the left, it's 2. We've done the right, it's 3. Are they equivalent? Okay, no. And so therefore, my limit as x approaches 2 of f of x, it doesn't equal 2 because they don't both equal 2. It doesn't equal 3 because they don't both equal 3. It does not exist because does not agree, or more mathematically, the limit as x approaches 2 from the left of my function does not equal the limit as x approaches 2 from the right of my function. Okay? Okay, last one here for the homework help video is number 13. Okay, so if you haven't tried number 13, go ahead and pause the video, give it a shot on your own, restart it when you're ready. Okay, 13a, we are approaching -1 from the left. Well, -1 is right here. Here's x equals -1. Approaching -1, getting closer and closer and closer to -1 from the left means we're tracing this side of the function, right? Getting closer and closer to -1 from the left here. What y value does it look like my function will be? Well, it looks like my function is going to have a y value of 2 as I get closer and closer to touching -1. Now it doesn't, there's no point there, but again, remember one more time, the point has nothing to do with the limit. The point can be there, it can be somewhere else, it can not exist altogether, and we don't care. The point is something else entirely, right? Has nothing to do with the limit. Limit is what does it look like my y value will be. As I approach x equals -1 here, it looks like my y value from the left is going to be 2. Okay? B, what about from the right? Now starting on this side, what y value does it look like I'm going to reach as I approach -1, get closer and closer and closer to touching -1 here from the right? As I get closer and closer to touching -1 here from the right, my y value looks like it's going to be 2. And so what about my two-sided limit? Well, because the left is 2 and the right is 2, these agree. So therefore my two-sided limit is 2. Okay? Okay, D, -2 from the left. So here's x equals -2. Approaching -2 from the left. So we're starting here, going this way, getting closer and closer and closer to touching x equals -2 from the left. What y value does it look like I'm going to touch as I get closer and closer to -2 from the left? Well, the y value it looks like I'm going to touch is -infinity, or does not exist because unbounded. So approaches -infinity or does not exist because unbounded. Okay, what about -2 from the right? Okay, we're getting closer and closer to -2. We're starting here, going from the right, getting closer and closer to -2 from the right here. What y value does it look like I'm going to be touching as I get closer to touching x equals -2? Looks like I'm going to be going to infinity, so it approaches infinity or does not exist because unbounded. And then what about -2 all together? Both sides. Okay, well, since the left is -infinity and the right is +infinity, those don't agree. And so therefore this does not exist because, and then you actually have two options here. You could say unbounded, because it is unbounded, or because it does not agree. The limit as x approaches -2 from the left does not equal the limit as x approaches -2 from the right. So I'm going to put ... here because there is more than one potential reason. Okay? I, by the way, prefer the unbounded within my own work, so maybe I'll jot that in parentheses. Okay, removable discontinuities then. Removable discontinuities, what are those again in your notes? Okay, removable discontinuities are holes. So where on this graph do we see a hole? We see a hole right here at x equals -1. And what about non-removable discontinuities? Okay, well, those are vertical asymptotes or jumps. Vertical asymptotes I know we did back in Unit 4. Jumps, I can't remember if we did or not. So those might be a little bit new, but look in the notes video if you want to see what a jump discontinuity looks like. But non-removable discontinuity, in this case, we only have a vertical asymptote, and our vertical asymptote is here at x equals -2. Okay?